Right, we're continuing to look at matrices, and we're going to consider having two matrices. The first matrix with dimensions m1 by n1, and this second matrix having dimensions m2 by n2. And if n1 is equal to n2, then we can multiply matrix 1 and 2. I'll double underline these, that the matrix shouldn't be like 1 and 2, but whatever. Yeah, so this is not the number 1 and the number 2, this is matrix 1. Let's put m1, m2 anyway. And m1 times n2 will have the dimensions m subscript 1 by n2. Okay, so if the outer dimension of the first matrix is equal to the inner dimension, and when I say inner I mean to the left, ours to the right, then we can multiply the matrices together. That operation is defined, and we'll see why in a minute when I show you how to multiply matrices together. And the best way to do that is just to get into an example. But the point is, if we can multiply them together, then the result we get has the dimensions of the first dimension on the left of matrix 1 and the second dimension on the right of matrix 2. So let's take two matrices and multiply them together. So we're going to take the matrix 4, 7, minus 2, 1, 3, 2, and we're going to see if we can multiply this by 4, 5, 0, 1. So the first thing to do is check the dimensions. This is 3 by 2, this is 2 by 2, so we've got 2 here, 2 there, so we can multiply these together, and the result we're going to get is a 3 by 2 matrix. So we can draw that out now, and then what we do is, when working out each element, we work across the rows of the first matrix and the columns of the second matrix. So here, for the first element, we do 4 times 4 plus 7 times 0. Okay, let's get rid of the second line and just give ourselves a little bit more room. Alright, and then for the next one down, so this is now the second row of this matrix, but it's still the first column. So we go down the second row of the first matrix and the first column of the second matrix. So we do minus 2 times 4 plus 1 times 0. Okay, and now for this third row and still the first column, we are on the third row of the first matrix and the first row of the second matrix. So it's 3 times 4 plus 2 times 0. And hopefully now you're seeing the pattern. This first matrix is what we use for our rows. So we're using these sizes, we find the dimensions of our matrix, and then when finding the ijth element, and when we say the ijth element, i's the rows, j's the columns, so we'll see a bit more of that later when we go on to this side now. So now we're back to row 1, but this is column 2, so we're looking at the first row here and the second column of this one. So it's 4 times 5 plus 7 times 1, and you just work through it formulaically like this, and here we have second row, second column, minus 2, 5 plus 1 times 1. And now finally, we're at the third row, and we're still in the second column, so 3 times 5 plus 2 times 1. And that's how you work through it. And then we work out all these sums, and this matrix comes out as 16, 27, minus 8, minus 9, 12, 17. Okay, a couple of important things to know. When we're dealing with normal numbers, so if A, B are real numbers, A times B is equal to B times A. Okay? But for matrices, if A and B are in the matrices, the same matrices, then A multiplied by B is not necessarily equal to B multiplied by A. You might get the odd example where it is, but I mean, if you look in this case, if we try to do this second matrix first, if we try to do 4, 5, 0, 1 multiplied by 4, 7, minus 2, 1, 3, 2, we can't even do that because this is 2 by 2 and this is 3 by 2 and 2 does not equal 3, so that's not even possible. So there's no way these can be equal, and even if it is possible both ways, it's not usually an equal matrix. So order is very important when dealing with matrices. So that's one thing to note. It's pretty simple to multiply these matrices. As I said, you just, for the first matrix, you use the corresponding row to the matrix you're trying to find out, and in the second matrix use the corresponding column, and you just work across and then add in each term as you go along. We'll do, I think, one more example to finish, where we'll probably deal with matrices of all the same size, just to try and make it seem a little bit simpler, I guess. We'll look at two 2 by 2 matrices. We'll go with 1, 4, 3, 7, and we'll multiply that by 2, 2, 1, 1. There you go. And you can always multiply square matrices with the square matrices are the same size, because of course they're 2 by 2, 2 by 2, so they're going to be equal. And the nice thing about this is square matrices multiplied by a matrix with the same size just give another square matrix with the same size, because you can see the inner dimensions and outer dimensions of both these matrices are the same. So we know we're looking for a 2 by 2 matrix, and this element here, but just to illustrate what I meant by the i's and j's, this element here is A1, 1. This is A1, 2, A2, 1, and A2, 2. Okay, and this is row 1, 2, 1, 2, row 1, 2, 1, 2. So this number takes us to this matrix, and this number takes us to this one. Okay, and actually what we can do is rub out these and those, because all we're looking for in this first matrix is the rows, and for the second matrix is the columns. So again, this one takes you over here, and this one takes you there, okay? And now in the next section we'll actually find all these values of a's. So 1, 1, we go 1 multiplied by 2 plus 4 multiplied by 1, well, that's 6. You see 2 plus 4, 6. Now for this next element, a1, 2, so we're still in the first row, as you can see by the little subscript here. So we're in the second column, so it's 1 multiplied by 2, that's 2, plus 1 multiplied by 4, okay, that's 6. Now 2 1s, we're in the second row, first column, 3 multiplied by 2, that's 6, plus 7 multiplied by 1, that's 13. Now we're in the second column, second row, second column, so again, second row of this first matrix, 3 multiplied by 2, that's 6, and it's just going to come out the same, plus 7 multiplied by 1, so that's 6 plus 7, 13. Okay, so that concludes this video. I hope this did make sense. It's a little bit different obviously to regular multiplication, but once you get the hang of it, it's pretty simple. Just always remember your dimensions. Don't get trying to multiply matrices together where the outer dimensions of the first matrix doesn't match the inner dimension of the second one, because you will get nowhere. Waste your time. If you did enjoy this video, please like